Hello everyone, welcome you all. Let's wait for a few more minutes to a couple of other participants to join. Okay, let's start now. Hello everyone, welcome you all. My name is Muthukumaran Ramalingam. You can call me Muthu. I work for AMI. Today we are going to present you the remote platform integrity attestation concepts, features, and some of the real-time use cases with AMI True. In the agenda, we have concepts, features, use cases, and question and answer sections. Let us start with a brief overview of the trusted computing and touch upon the trusted computing concepts. Move on to the remote attestation features that includes introduction of platform security solutions from AMI. Then we will explore the real-time use cases for remote attestation. Finally, we will have enough time for a Q&A session. We will try to answer your valuable questions and comments. Let us make this webinar as a discussion. When you have any queries or comments, use the questions window. We will be trying to answer all queries as quick as possible. Let's start with the concepts. Under the concepts, we will be quickly touching the trusted computing concepts like chain of trust, hardware root of trust, and platform attestation. What is trusted computing? Let us start with what is trusted computing. Trusted computing consists of set of industry standards defined by Trusted Computing Group called TCG. These standards help to harden the systems and data against any attack. These standards include verifying the platform integrity, establishing the identity, protection of keys and secrets, and ultimate aim of this trusted computing is to provide the trusted platform by enabling the concepts like chain of trust, root of trust, and platform attestation. Let us go over the concepts one by one quickly. Verifying the integrity of the underlying platform is the key concept of trusted computing. This typically means that the process by which the measurements and verification takes place in a defined order. and assert that the measured and verified components have not been altered. This is what we call it as chain of trust. Any break in this chain leads to an opportunity for an attacker. The block diagram on the right side shows the very top level workflow of the chain of trust. It starts from the BIOS boot block and ends with an optional application running in the operating system. The cryptographic measurements from each stage of chain of trust will be stored into a secure crypto processor called Trusted Platform Module, generally call it as TPM. The TPM technology is designed to provide a hardware-based security-related functions. The TPM chip includes multiple physical security mechanisms to make it more secure. Also, the measurements from each component is appended to the previous measurements and build a cumulative hash of each stage of chain of trust. Basically, TPM has has a crypto engine, and it also has a PCI registers to store independent measurements, individual measurements that support different cryptographic algorithms. Also, it has a non-volatile storage and other components, and finally it has a I/O component which talk to the outside world. So basically, the chain of trust starts with the boot block, and then BIOS. BIOS will also handle the hardware related measurements. Then it goes to the OS loader, then the OS. Then if there are any applications that is part of this chain of trust, that also be included its measurements into the TPM. Hardware root of trust. Hardware root of trust is the first link in the chain. It can be one of the different options available as part of the chain of trust. But hardware root of trust should start very early in the system boot process as much as possible to keep the wider coverage of the chain of trust during the boot process. Anything that happens in the boot process before the hardware root of trust should be considered as within the trust boundary. Hardware root of trust will have a very smaller trust boundary. So there are many hardware root of trust implementations exist. Intel provides Intel TXT and Intel boot card kind of technologies for its hardware, for its platforms. AMD provides AMD secure processor and AMD secure boot kind of technologies, and ARM is also providing a trust zone. These technologies are doing much more than that hardware root of trust, but these are all the kind of sample-like implementations for hardware root of trust by different silicon vendors. Also, new platforms now support UEFI secure boot, and silicon vendors build the security implementation on top of it. AMI is providing a vendor-agnostic hardware root of solution called Tectagon. We will be seeing more details about what is Tectagon in the upcoming sections. Platform attestation is another concept of China like trusted computing. Platform attestation consists of primarily of two activities. One is measurement, another one is attestation. Measurement is an act of obtaining cryptographic representation for a system state. Attestation is an act of comparing those cryptographic measurements against expected values and to determine whether the system is booted into an acceptable state or not. So in this webinar, we will be focusing more on the platform attestation features and concepts and what are all the real-time use cases we can build on top of the platform attestation, especially as part of the trusted computing. So attestation can be either local or remote. Local attestation, let us have a quickly touch on what is local attestation, then we will be focusing more on the remote attestation concepts. A trusted boot process can include a local attestation optionally. It involves the evaluation of the launch control policy stored in the TPM. The boot process will compare the measurements taken to a set of expected PCR values stored in the LCP. Then any problem or mismatch happened in the boot process, the boot process will be entirely stopped. So local attestation is kind of proprietary implementation on a specific hardware. The hardware vendor need to implement that, and that has a lot of challenges in order to expose the information, or a system will be halted, all these things. On the other side, On the other hand, remote attestation is handled by an external service. The remote attestation service maintains a database of expected measurements. The remote attestation service compares the actual boot time measurements from the host and provides the results of the host booted into a trusted or untrusted state. The remote attestation is easier and centrally managed so that the information, the attestation information can be consumed by like any other orchestration layer components. Remote attestation also does not halt the boot process. Instead, it will notify the changes detected as part of the overall system state to the administrator, so that administrator can take remediation actions, what to do and how can they mitigate that issue, something like that. Any questions so far? Okay, let me proceed with the features. So now, hope you all understand the basic concepts of the trusted computing. Let's start with the chain of trust, root of trust, and what is the remote attestation. Under the features on the remote attestation, using the remote attestation, we will be walk through some of the trusted computing features that can be implemented using the remote attestation concepts listed here. We'll start with platform integrity, and then data sovereignty, and then application integrity, then platform security solutions from AMI, a quick introduction on platform security solutions from AMI. And we also listed down some of the sample PCR definitions. PCR means platform configuration registers, which is part of the TPM. How the PCR values, different measurements will be stored in different PCR registers. We'll be showing a sample implementation of that. Platform integrity. This feature helps in identifying the overall trust status of the platform. This is a foundational use case for all the platform attestation concepts. It involves the hardware root of trust to provide the unbroken chain of measurements of a platform at boot time. These measurements can be extended to the TPM and stored securely in the TPM. These values are compared against the expected values and to verify the integrity of the measured components. The well-known measurement, we call it as flavors, that will be stored in the database of the attestation service. We will be explaining more on what is flavor and how are we going to collect those information in the upcoming slides. So as I told, platform integrity attestation is the very basic concept that is a foundational platform security mechanism that will be extended to the other use cases like data sovereignty and application integrity and other use cases we are going to discuss on the upcoming slides. Data sovereignty. This feature extends the platform integrity by adding the user-defined key-value pairs. We call it as asset tags. These values will be written into the physical TPM of the platform in a secure way. These values can identify a geographical location of a physical server, or it can represent a regulatory or legal compliance like CCPA, California Consumer Privacy Act, or HIPAA, Health Insurance Portability and Accountability Act, PCI, Payment Card Industry, a kind of information. Any additional information, any external information you want to add as part of your server, for my server is sitting in this particular geographical location, my server is sitting having this kind of compliance, we can run this kind of workload on this particular server. Those information can be pushed to the TPM and stored it in a secure way. Only the platform attestation solution can read it and evaluate it against as part of their attestation whether that data stored in the TPM has been tampered or not. So this data sovereignty use cases allows the data center administrator or edge administrators to take care of their servers and label their servers for certain compliance, compliance and regulatory information, and especially geographical location, so that can be consumed by the orchestration layers we will be seeing in the upcoming slides. Yeah, we are seeing a question here on the questions window. Can you explain the differences between the TPM and trusted execution engine? We will be collecting these questions and we will be trying to answer as much as possible at the end of the session. And the other use case, other feature of the trusted computing is the application integrity. So far the platform integrity use case is taking care of the firmware, and the additional information will be stored as part of the data sovereignty use cases, and the application integrity is taking care of any Linux host file systems can be part of the chain of trust. So any features, this is again extension of the platform integrity to the OS level components in the file systems. This allows any files in the Linux host system to be included in the chain of trust integrity measurements. This will be taken care by in our implementation. This will be taken care by adding a special scripts into the init during the agent installation. These measurements calculated at boot time and used for remote attestation. So the remote attestation report will be showing the results of the application integrity as well. AMI is when it comes to platform security, AMI provides security solutions for both platform root of trust and remote attestation. AMI Tectagon. Tectagon is a state-of-art hardware root of trust solution from AMI that detects and tampering of platform firmware code and critical data, recovers the platform by restoring the platform firmware, and continuously monitor the platform for its firmware protection. You can visit our website www.ami.com to know more on the product called Tectagon or platform security or platform root of trust solution. AMI True is the remote platform attestation solution, offers end-to-end platform attestation features for data center and edge platforms. Once the platform is registered with the AMI True periodically monitors the platform and generates attestation reports. It also handling the attestation immediately after the platform is rebooted, which is where any tampering happens on the platform firmware will be reflected only on the system reboot. Because of the platform attestation and reboot is happening, any tampering of the platform in the security will be identified as soon as possible. So AMI True also notifies the state changes events to the data center administrators. So it also offers out-of-band management capabilities and remediation options like firmware update using Action Service Framework. So as part of the standard management solutions. To know more about AMI True solutions, you can again visit our website www.ami.com/attestation to know more on AMI True solutions. Here are some of the PCR definitions as part of the features we have added as part of the presentation. So this information is collected from a Red Hat 8 on with the TPM2 on an Intel platforms. So start from PCR 2.0 to PCR 19, some of the PCR parameters, some of the measurements stored in these specific PCR registers, like PCR 0 stores the BIOS, ROM and flash image if Intel boot card is available. PCI 7 is specifically for Intel boot card configuration, since we have collected this information from Intel boot card. And PCI 15 is specially used for software flavors by our application. So PCI 7 is for ACM and PCI 18 is for MLE for like legacy BIOS with the T-boot options. PCI 19 is used for measurements of the operating system init-RD and the UID of the platform. These are some of the sample PCI definitions. All the like PCI definitions based on the TCG like TPM specifications. Let us walk through the all the use cases one by one. Any other questions before we go into the use cases section? Yeah, we see one more questions like difference between the TPM and the trusted execution engine. Basically, TPM may be a piece of hardware, and from my understanding, and TE is nothing but a chipset that works like a TPM. So it's not basically isolated. So that's the difference between the TPM and the trusted execution engine. Yeah, the other question came is like, does AMI uses any TCG or IETF standards to transfer measurement data from endpoint to the remote attestation server? Yeah, I would say yes. We have like security libraries implemented, and the data transfer is purely on the secure server. That the data transfer is initiated by adding a root CA on the. We have a certificate management server and authentication server. So when we deploy the component on the agent on the host machine, so all the deployment will be stored. So the communication is secured. So I would say we are using TCG standards to transfer the measurement data between the endpoint to the remote attestation server. Other question came up here is how does the platform know when the platform firmware code is compromised? Yeah, that is what we are going to see in the upcoming slides. The platform, we have measurements taken from the platform, and that measurements will be validated against the good known measurements taken earlier. That I will be explaining more on that in the upcoming use case slides. So when it comes to platform attestation, let me start with the generic attestation workflow in a slide. So to answer your questions, how does platform know the platform firmware code is compromised? The answer is here in this slide. So basically, the attestation requires an expected measurements to be collected from a good known trusted platform. And we call it as golden measurements. It can be done from a manufacturer side. In this slide, you can see three different boxes. On the middle, it's an attestation solution. Right side, all the managed servers. On the left side, good known system. Or the good known system can be one of the system within the data center or the edge environment itself. So the platform attestation service collects that information from a good known system, and we call it as flavors. Earlier in one of the slide I mentioned a term called flavors. We call it as flavors, and that flavors will be stored in the platform attestation service measurements. When the host, when the platform is registered to the platform attestation service, so internally we will be identifying the appropriate flavors for that the host and associate that flavors to that one. That means the like expected measurements to be taken from validated from these particular list of flavors, something like that we will be associating with it. That depends on the what type of platform, what OS is running, whether it is RSL or it is Ubuntu or any other platform, what type of chipset it is. So there are so many different factors. So based on those things, we'll be collecting that information, and we will be like associating the flavors. Then the platform attestation service installs the agent on the target machine, and the agent in collecting the information time to time. When there is a request, the agent collect the information and send it to the platform attestation service as the current measurements. The current measurements will be taken into account and validated against the good known measurements, and find the attestation like report. That attestation report says that whether the host is in the trusted state or in the untrusted state based on the different parameters or different components measurements taken into account. I hope I answered your question. So this is the generic attestation workflow. On the remote platform attestation service, periodically do an attestation on the host platform, register to it, and produces the attestation report. The attestation is also happening on system reboot in order to make sure that any tampering that can be occurred in the system, on the system firmware and system reboot, that will be taken care and that will be identified as soon as possible. So this is a very generic like platform attestation concepts. Let us jump on to the use cases quickly. The use cases slides are created such a way that what is the problem statement and what is the solution offering from AMI and what kind of value it adds bring to the customers. So that's the problem statement, solution, and value. So let us start with the very foundational security use cases like the platform integrity attestation. Here I have a platform. I want to be monitored for platform security. What should I do? That is a question all the data center administrators have. People are talking about platform integrity attestation, platform security, trusted computing, all these things. I have a platform. This is my hardware configuration. What should I do? So in order to start the platform integrity attestation, we need to register the platform with AMI True, and the AMI True will take care of the attestation requirements and produce the attestation reports. So once the platform is registered with the AMI True solution will continuously monitors that one and monitors that host and do an attestation based on the expected measurements you associated with it, and then the information, the attestation report will be produced. That attestation report can be consumed by the administrator like you. So this is a very basic platform integrity use case, attestation use case, where the end user will, the administrator will get the overall trust status of the system based on the expected measurements. Second, moving on to the next use cases, the data sovereignty use cases. Data sovereignty, as we discussed earlier, asset tags like key value pairs. The foundational security use case covers the like firmware, everything is automated, so the measurement taken, validation report. I want to add my own like labeling, so some labeling, like I want to tag my system with certain key value pairs. So that can be achieved using this data sovereignty use cases. So what is the like problem here is like I have my system like monitored for platform security, and I want to add some additional information. I want to use some additional information what is the location, how can I add a location of my server in a safest method, or how can I add like my compliance information of my server into in a secure way, and how can I make use of this. So using AMI True, we can deploy the external information as a key value pairs. Any number of key value pairs, you can add it as an asset tag and securely into the TPM. These asset tags will be stored in securely into the TPMs, and then the asset tag values are again stored in a hash value. So the AMI through attestation service will have the keys internally and encrypt it and keep only the hash values there in the TPM. So anybody who really wants the TPM from other applications cannot even read. Even they read the information, they cannot see what is inside, what are all the tags will be stored, something like that. And asset tag will also be part of the platform attestation. If there are any tampering happening on the asset tag measurements, that will be informed, notified and identified and notified to the administrators. Using this use case, data sovereignty use case, you can also extend the platform capabilities with a different set of user-defined key value pairs. That's what we call it as asset tags. So this basically extend the previous foundational security use cases. And application integrity. I want to protect certain files in my file system, like attestation agent should not be replaced, or something like that, or any other Linux file system or anything should not be tampered or modified. So how can I do? So with the set of software flavors created and imported from AMI through, the application measurements are taken at the boot time and used for attestation. So at the time of agent installation, we will be creating a setup, running certain scripts, and that scripts are collecting that information of the measuring the information, collecting the measurements from those files you have provided, and then keep that information in a file system and share it to the attestation server. So the application integrity on every system reboot, the measurements will be taken again and again by the init.rd component, and that will be sent to the attestation service, so that the attestation service will carefully validate against the whether applications are tampered or not. So this is about the application integrity. In order to do that, you have to just create additional software flavors. We have options to provide the software flavors, and the application measurements will be automatically taken care of on the next system reboot. So far we have gone through 3 different use cases. One is the foundational security, platform integrity attestation. Second one is the extend the foundational security with the data sovereignty use cases asset tags. And then how can we protect the applications by adding the software flavors into it. One more question, coming back to my previous question: do you support the TCG standard or TCG attestation protocol information model version 1.0 revision 3.0 September 2.9 to transfer TPM to attestation data? Yeah, the version and the specification version information we will get back to you. So at this moment I do not have the version information. I will get back to you on that part. With all the above use cases explained, now you may have questions like: I have the system monitored and protected for platform security and extended my platform integrity by adding attestation for my applications. I also added application software flavors, everything. I also updated my system location and regulatory compliance capabilities, all this information. What should I do with this information? How can I utilize them? So this is the questions everybody will have it, right? So I'm handling it, but how can I? What is the purpose of this information stored or information is being used? So here is what we call it as a use case, one of the most real-time use case as part of our solution is like the launch time protection with the cloud orchestration integration. Our product supports cloud orchestration like Kubernetes. So what we will do is all the attestation information and asset tags and application information will be pushed to the Kubernetes orchestrator, the control plane node, as a Kubernetes labels. There is a concept called labels in Kubernetes where we can store like a kind of a key value pair as labels, and that can be consumed, that is associated with a specific worker node, and that can be consumed by the Kubernetes orchestrator. Then these label values will be consumed by the Kubernetes orchestrator as a kind of like policy decision. Suppose I want to run my workload in a specific trusted host, or I want to run my workload on a system in which this system should be running in the specific geographical location, or it should have the compliance with the specific regulatory compliance like HIPAA, PCI, or like CCPA, something like that. So this integration helps in administrators to launch the workload in order to run the application or the workload on the trusted platform, to make sure that the workload policy, the manifest, they can edit the workload manifest and add launch time policy condition, launch time conditions. Hey, run this workload, only this workload requires a specific constraint. Okay, this workload need to be run on a PCIe compliant server or HIPAA compliant server or CCPA compliant server, or this workload should be running on the specific geographical location, server in the specific geographical location where the data center servers are distributed across different locations. So these are all the kind of control launch time policy. They can be applied as part of the workload manifest. Then the workload will be launched based on that the server. So AMI True working in the back end and providing all the measuring, the take the measurement and identifying the trusted server's trust status, and that information will be shared with Kubernetes orchestrator layer like Kubernetes, and then Kubernetes is making use of this one. This is the one of the typical real-time use cases we are supporting. We call it as launch time protection use case, launch time protection.
Yeah, it's like on that corner. Yeah, it's.
But I never actually.
That's actually the. Okay.
It is work.
Yes, it is. Got breakfast.
Yeah, that's it about with this.
That's it.
We are into the final part of the webinar. We hope that you have a better understanding on the remote platform attestation concepts, features, and use cases with the real-time, one of the real-time use case. Any questions or any other queries, comments?
Dying. As
Part of you. Thanks.
Yeah, I mean, fine, if that's what you want to try that, I can get whatever. It doesn't really matter.
Okay, there are a couple of questions popping up. How is the platform recovered when the remote attestation there is a compromise? Yeah, this is a very good question. AMI True notifies the issue which PCR data is breaking, or which application data is breaking to the administrator. Then administrator can initiate the remediation options from as part of our product offering. AMI True also supports remediation options like BIOS, firmware update, and application remote installation, all these things. So using that, they can direct the mitigate the problem and then make the server into the normal state. But because of this involves in the firmware related stuff, applying firmware automatic remediation and all is possible, but that requires an approval from an administrator in the data center. That's why we haven't automatically do any remediation actions. But in future time, we can define some policies. Based on that policies, the automatic remediation is also like AMI True has some analysis, and then it can also initiate the remediations automatically. We are working on that part in the future releases. The other question is, how many flavors can you reasonably expect in a given model? Yeah, there is no limit in the number of flavors. It depends on the number of platforms on a particular platform firmware or something like that. When there is a upgrade in the platform firmware, then we should create a new flavor for it, something like that. So that's the overall solution we are providing. So whenever there is a new platform flavor, new firmware is upgraded, then we need to import the flavor and associate that flavor with that system, so that the new measurements will be taken into account. Other question is the file measurement happening at runtime or at boot time. So runtime tampering cannot be detected. It's done at the boot time. Yeah, as of now, the file measurement is happening at the boot time, because the measurements we are taking through the init process. So the measurements, any tampering after the boot time, we cannot detect as of now. What if the host platform is uncooperative to remote remediation request because it booted into compromised firmware stack? Yeah, this is a good question, but from my understanding, the remediation action for now is totally in a standard way. If platform is not cooperative, that need to be taken care in a separate way, how manually or changing the firmware chip, all those things. So as of now, we do not have a solution for that. So when a host platform is compromised firmware stack, having the compromised firmware stack, there are a couple of quick remediation options possible. For example, when a host platform is compromised, AMI2 detects that the platform is into untrusted state. So as part of the remediation, the data center administrator can decommission the system, because this is not a trusted one. They can simply decommission the system from the deployment and try to recover it. That's a kind of extreme use case I'm talking about. So by that way, they can at least detect and isolate the compromised system from the environment. The other question is, how can the trust agent block the unauthorized SPI SMS transactions when there is a compromise? So trust agent is not talking to spy or monitoring the system. It just collect the information from TPM and it is send it to the interfaces. It is send it to the host attestation server. The current measurements, the measurements are added to the TPM at the time of boot. So it is not monitoring any spy or some bus transactions. Other question is like, does your solution support both in-band and out-of-band channels for the host integrity report collection? As of now, we are supporting only the in-band way of doing things, but we are actively working on providing the out-of-band channel, collect the information through the out-of-band channels. So we are, as a AMI is a bias and BMC company, we are already started working on that area, collecting information through out-of-band channels. Other interesting question is how the trust agent itself is protected. Does the trust agent run in an isolated or trusted execution environment? Yes. As part of the software flavor, as I explained about the software application integrity, the trust agent binaries are by default included in the software measurements. So any changes or any tampering in the agent will be easily identified. So it will be part of the OS environment, but the applications and files are protected. Another question pop up, like how is the golden image managed? The golden image is imported from the golden measurements are imported from the good known system, either in the manufacturer side or in the one of the known system from the customer, data center side. So the data center administrator need to make sure that the system is not compromised, so that can be treated as a golden measurements.
Alrighty, barring any other questions, we'll go ahead and conclude this webinar. If there are any remaining questions after we close the line, you can send them to admin@trustedcomputinggroup.com, and we will make sure to put you in contact with folks that can answer any of your questions. Thank you all for joining this wonderful webinar. And thank you to our presenter as well.
Thank you all. Hope you all now have a better understanding on the remote platform attestation concepts. So hope you enjoyed the webinar. Thank you so much for your inputs and comments and questions. One question I need to answer the exact version number we are using. If you can provide your information, we will be sending that information to you in an email. One other question we are receiving now is like, does this system enforce secure boot? Yeah, we recommend secure boot for our implementations in order for platform security, but that is not necessary, because secure boot is the most latest technology. We also support a legacy systems, legacy BIOS systems. On that systems, we may need to install the software component called T-boot in order to support the platform attestation features. So we support both things, but we are not enforcing secure boot. If secure boot is not enabled, some of the measurements won't be available. That's it. But we recommend to use the secure boot as a default what you call option for the platform security. Yeah, without secure boot, BIOS can compromise measurements. Yeah, the latest servers all have the UEFI secure boot enabled. So we recommend to enable secure boot in all the platforms for wherever we are using platform security interfaces. But on the other hand, we are also supporting non-secure boot available systems like old legacy BIOS systems by installing T-boot component on the operating system level and take the measurements. And thank you so much for your comments and questions. Have a great day ahead. Thank you, TCG, for giving us an opportunity to present this to the audience. Hope everybody enjoyed the presentation.